Okay, well, my name is Rubén Casado, and I'm managing big data team at Accenture Digital in Spain. In addition, I'm the organizer of the Apache Flink meetup in Madrid. Today, we are going to talk about how to implement Kappa Architecture and a first approach to use and to put together Flink and Apache Kudu, because we think they are good technologies to do that. Well, this presentation is divided in this section. First, I'm going to provide some context, some motivation about the work that we have done. I will introduce why we want to use Kudu and what is Apache Kudu. Then I will provide some details about the implementation of the connector that we had to do. Then I will show some examples, and if I have time, I would like to do a very quick demo. And finally, some comments about our contribution and our relationship with the open source community. Well, let's start with the introduction. Well, when we started talking about big data 10 years ago, that's quite time ago, we always were talking about the three famous popular problems: volume, velocity, and variety. And we had three solutions to deal with the problem. We had batch processing to be able to manage large amount of information using distributed parallel process, We had streaming processing to provide low latency in real-time results. And of course, we had a NoSQL system in order to manage and query the information using different ways. But we had another scenario when we had to take into account not only the streaming data, but also the whole historical information. Some authors call it a new processing paradigm, like a hybrid computation model. I'm quite sure that all of you here know what is the solution to that problem. That is the popular land architecture defined by Nathan Marr in 2011. With the land architecture, we basically have a batch system to process all the information. Or in order to compensate the delay, we also have a streaming processing system to compensate the delay of the batch jobs. In order to provide the result for the end user, we have to combine both results. Well, something that we have to take into account when we are analyzing this system is that it was defined in 2011. So in those days, the batch processing technologies, HDFS, Hadoop, and so on, were very good technologies and production-ready technologies. But the streaming technologies, basically S4 from Yahoo and Storm, they were not as powerful as they are today. So in the following years, due to the release of more powerful technologies, Kafka, Samza, of course, Flink, a simplification of this approach was defined by Jay Creeves from LinkedIn, and someone it's coined like Kappa Architecture. Of course, the Kappa Architecture is a totally different approach. It is a log-centric system, and it understands the system like an open database. But at the end, it provides a solution for the same problems. In Kappa Architecture, all the information is managed like streaming data. So we need a streaming processing engine, and also we need low latency for random read and write information. And in order to be able to work also with historical information, we need that the information has to be replayable. Okay, how can we implement a Kappa architecture? Of course, there are plenty of alternatives. There are very good technologies out there to use. But this is, we think, is a quite interesting approach. Of course, we have Kafka, because it's a very good technology to manage the streaming data, but also to replay the information if we need it. We have Flink as the streaming engine, since it's the most advanced streaming engine right now. And we think that Apache Kudu is a quite interesting technology for the serving layer. So what is Apache Kudu? Well, Apache Kudu is a new storage system that combines an efficient access to random data with a good performance analyzing large amount of information. Apache Kudu is a columnar-oriented system. It's for structured information, and it was developed by Cloudera, but right now it's a top-level Apache project. Well, Kudu has a native integration with Impala and Spark, but not with Flink. The question is, do we really need another storage system in the Hadoop ecosystem? We already have HDFS, we already have HBase. Well, HDFS is a very good technology for writing once, reading many times. But of course, always talking about large amount of information. HDFS is not suitable technology if we want to access to random data. If we want to modify or read just a specific key element. On the other hand, we have HBase. That is a very good technology to this kind of scenarios when we need the key of the element, so we know what element we want to get or write, but it's not efficient for executing large scans. So for analytical process are not the best option. So at the end, when we need the two different access patterns, we usually have to put both systems, HDFS and HBase. Well, that scenario will be a very nice scenario to use Kudu. Because with Kudu, with a single storage system, you can provide a mix of the features of both systems. Good performance accessing to random data, but also good performance reading and writing a large amount of information. In addition, Kudu provides a relational data model. How is Kudu? Well, as I have said, Kudu is for structured information, and it provides a relational data model. So we can get the features that we already know. We have SQL, we have function scheme, typed column, and of course we can modify not only the information, but also the tables. The architecture of Kudu is quite simple. It's something similar to HBase, maybe. There is a Kudu master in charge of managing all the operational metadata operations in order, well, the Kudu master knows where the information is. There are more than one Kudu master in order to ensure high availability. All the information that we store in Kudu is stored in tables, and each table is partitioned into tablets. The tablets are replicated into different servers, following a leader-follower model. Of course, any of the replicas can provide response to a read request. Well, as we have seen, Kudu is good for fast data, also for batch data. So we think it fits very well in the Kappa architecture scenario. So we wanted to put all this technology together. So let's see how we have done it. We wanted to be able to work using information from Kudu, using the both Flink APIs, so from DataSet for batch processing and DataStream for streaming. And Flinks provide a way to extend the source and sinks. So our goal was to create a new source in order to be able to read information from a Kudu table. That scenario we think is relevant only for batch processing. And new sink to write the result into a Kudu table. In this second scenario, we think is quite interesting for both batch and streaming scenario. So basically, we had to implement these different connectors, Kudu input format to read with the dataset from a Kudu table, to write the result to a Kudu table using the dataset, and to write the result to a Kudu table using the DataStream. So let's see very fast how we have to do it. The first one is Kudu input format in order to read from a Kudu table. Basically, we had to create a new class that we call it Kudu input format, which implements input format abstract class. There are several methods that, of course, you have to do, but the most important one are open to get the connection, to achieve the connection to the table that you want to read from. Created input split that transform the Kudu's tablets into Flink's input split object. And then, next record, just to read the following row in the Kudu table. Once we have defined this, we can use something like that. Using the Kudu input builder, we can define the table name, the Kudu master IP, and we get a data set of row serializable objects. We have to use this new row object or new class because the Kudu API provides an object that is called result row that is not serializable. So we had to do this wrapper. Well, very fast with this detail. Basically, with the in the open method, we had to get the connection to the table that we want to use and obtain the scanner object, or to prepare the scanner object just to be prepared to read information. Created input split basically transform the tablets into input split from of Flink. We have to create a new input split object, quite simple. It is not complicated at all. And next record, that basically using the Kudu API, we transform the Kudu row into a row serializable Flink object. As I said before, we have to create this wrapper. Well, the next one is the Kudu output format to write the results to a Kudu table. Something quite similar. In this way, this time we had to extend the Flink rich output format. There are several methods. This again, open to get the connection to the table that we are going to write, and write record just to transform the DataSet row object into a Kudu row. We use something like that, Kudu master, table name. Something important is the mode. There are different modes to create a new table, override if the table already exists, and append to include the results in an existing class table. Sorry. Well, in the open method, something important to say is if we are using the the append mode, we have to check that the number of the columns are the same, that the type of the columns are the same, and everything is OK in order to ensure a robust process of the information. Remember that, or recall that we are working with structured information. Kudu is a relational database system. And yeah, well, write record, quite easy, just to transform the row serializable object into a Kudu row. And finally, the Kudu sync, that is quite similar to the previous one. In this case, to work with the DataStream API. We have the open method and the invoke. The invoke is really similar to the write record. So we can use it in this case, add new sync, the object, Kudu master, table names, and the name of the column that we are going to create. The invoke method, that is really similar to the previous one. Of course, there are more methods that you have to implement. I would like just to say this is not so complicated to do. Well, let me show you some example about how and when we can use it. Basically, there are two types of scenarios when we can use it. One is for batch processing, another is for streaming. In batch, maybe you need to read information from the Kudu table. Maybe you need to write the result from your dataset object to a Kudu table, or maybe you have to do both. You have to read from a Kudu table, execute some transformation, and then save the results in a Kudu table. In this other scenario, that is the streaming one, we think the most common one is you read from a streaming source like Kafka, and then write write to a Kudu table. Since I don't have too much time, just to say that in the GitHub repository you have job example of all of these kind of scenarios. Let me show you some code example. This is for batch. Basically, we get the execution environment. Using the builder, we create a data set. We read from a table. So here we are transforming a Kudu table in our dataset object. We execute the transformation that we need. And finally, we write the result to another Kudu table. Quite easy. And basically the same for streaming. We get a streaming execution environment. We define the properties of Kafka topic. We get the information for a topic of Kafka, and we execute a transformation in order to change from a string or whatever we need to a row serializable that is the object that the thing can write to a Kudu table. OK, let me show you a demo in order to ensure that it works. Oh, I cannot show you the screen. Excuse me. I don't know why you cannot see the screen. I have a problem. I cannot show the screen. Excuse me. Just one moment. OK. OK. OK, what we are going to do is to insert something. Well, let me check the table that we already have in Kudu. These are the tables that we already have. Let me clear one of them. Okay. These are the tables that we have. This code basically gets execution environment. It creates a data set from elements with 2 elements that will be transformed into 2 rows. We execute a map function that basically add a new word, add a new to each field, and then execute. Okay, let's check. Here, as you can see here, we are going to create tablet with the name Flink forward, and the mode is create. That is the parameter that we need here in the output. Okay. Come on. Okay. Okay, everything is okay. Let's check using the Kudu. Now we can see that here we have the new table. And now what we are going to do is to read from this table. We are going to read from the same table using the Kudu builder, and we are going to print the result into the screen and also to write as a file. Just to let you know that we can use whatever we can do with the DataSet and the DataStream APIs from Kudu. Here you can see that we can see the elements and also the files that have been created here. Okay, different files. Well, let me go back to the presentation. Well, something that I would like to say is that this work has been mainly done by undergraduate students that are doing an internship with us in Accenture Digital in Madrid. I wanted them to learn Flink, to learn Kudu, but the most important goal was to encourage them to use and contribute to the open source community. Okay, so if you review or use the code, don't be so hard on them, please. Here you have the GitHub repository and also maybe in dependency. I think it's quite out of date. Maybe you can get the code here. Actually, in Accenture, we are doing some project with Flink and Kudu, so we really like it, and we are going to do a production-ready version of this connector in the coming weeks. But of course, any contribution is really, really welcomed. And as I said, I want my students or my team to use and to contribute to open source community. So we were looking for what is the best place to put this code and the next version of this code. And it is Apache Bahir. I don't know if you know what is Apache Bahir. It's basically a Apache project to extend distributed platforms like Flink and Spark. We are doing the following steps. Firstly, we had to open a Jira ticket in order to define what we wanted to contribute. After several weeks, we received, the ticket was assigned to us. Then we were able to open a pull request, submitting our code. And after several weeks, we received some feedback, some change that are needed to do the code. Here, we are currently on this step. We are doing some changes. Of course, we need to improve the code to be included in the repository. But hopefully, in the incoming weeks, we can push the new version, and it will be integrated in the project. Well, that's all that I wanted to say. That's to conclude, just to say that Kudu and Flink are very good technologies to define Kappa architecture or streaming architecture or whatever you want to call it. We have done a first approach to put these two technologies working together. This is a good exercise for people to contribute to the open source community and learn. That is quite interesting thing that we have to do as software developers. And that's all. If you have any question, thanks for your attention. Anyone?
Hi, Rubén.
Hi.
You said that you are already working with this for any project in Accenture. So could you share with us any of the use cases that you are working on?
Yeah. Well, yes. The first one is for a financial service client. That what we want to do is to create the context of the user profile in real time, always up to date. So we are getting all the events from the website, processing with Flink, and let's say write the fingerprint of the user in Kudu. So of course you always other different microservices can get the updated information, but also the data scientists can read the information and train the models. Thank you, everyone.